Next, we look at a relative motion. What happens if you have two body that is moving, right? So in the previous 1.6, we only look at one reference point and then one object is moving. Now we look at what happens if we have two moving objects and we find the parameter that relate both of them. Okay, so in this section, we will look at the motion that related to two objects. So something like pulley. So if you pull the string, you have three pulley there and an object. So basically, in this diagram, you see four objects that related to each other by one individual string. If you pull the string, right? If you pull the string, the mass is moving up. The pulley also moving up. The bottom pulley, the middle pulley doesn't move. The top pulley doesn't move. So we're going to derive equation that related to the object in our system. So in this session, we're going to focus on blocks, cords, and pulley to illustrate the relationship of two bodies. Okay. We're given this diagram to illustrate. So if you can look carefully on the diagram, basically you have two blocks, block A and block B, connected with a cord or with a line, and through a pulley at the center. Okay. So before we solve any question, we need to know our coordinate system. All right. So ask yourself, when you're given two body with a pulley or with a reference position, in this case, we are looking at pulley system. It can be changes to other scenario. Always ask yourself, what is the coordinate system? Okay. When you talk about coordinate system, ask where is your origin. In this case, we lock our origin at the center, which doesn't move all the time. In this case, we lock at the center of the pulley that doesn't move all the time, 0. We have object A, object B, and our coordinate system, we are interested to find the position of that particular object. In this case, if you are referring to A, we use S sub A to represent the position of our A from the datum. So in this case, as you can see from the diagram, we have two different datum. One datum is for object A, one datum is for object B. And I want you to look carefully into the diagram. There is a direction for your position as your SA, right? Since the beginning, we derive equation for position. Position also, there's a direction. So SA, there's a direction. In this case, the direction is pointing down to the left-hand side from the datum. Okay, so in this section, pay a little bit more attention to the direction of the parameter that you use. In this case, SA always refer to the datum and is always give you a positive direction, a positive value of your direction. In this case, if you look carefully on the SA, there's an arrowhead at the bottom there. The datum, we always use a small dot to represent the tail or the starting point from the datum to the location of the body. For example, SA, positive direction from the datum is going down. What about B? B also have its own datum measured from point D, and the positive direction for object B is in this direction. That's why you see the arrow with the dot and arrow. So SB to this direction is positive. And in this diagram, you try to imagine what happens if you pull in one of the objects. If you pull B, A is going to move up. If you pull A, B, you're going to move up. So this section is going to study the motion or relative motion to two body. Okay, so I'll give you 10 seconds or 20 seconds. Just look at the diagram. So are you able to identify the coordinate system? Where is the origin? How you calculate the position to that particular object? All right. Next, we move on. These are the marking point that I just mentioned to you. Identify where is the origin. In this case, fixed point O, or where is the origin. Second one is the direction of your motion. In this case, A have its own direction, B have its own direction. B is that always look into the diagram and fix where is the positive direction from the datum. Okay. These three things is fundamental when you want to solve relative motion kind of question. Identify where is the origin. Identify the direction of the movement. Number 3, define where is the positive direction from the datum. These are the first 3 fundamental steps when you want to solve relative motion. Okay. So in this case, I just draw a positive sign there just to indicate SA is positive going down for object A, B for object B going down is positive. So ask yourself this question. What happens if I pull A with the SA value positive? What happened to B value? Will it be positive value for SB or negative value for SB? Try to think about that. I repeat the question. By having said the positive direction of your SA and SB, try to relate, just the logic thinking. You try to pull A in the positive SA direction. What will happen to your SB value, or what will happen? Yeah, what will happen to the SB value? Will it still maintain positive or negative? Think about that, right? We start to derive equation for the relative motion between two bodies.
Sir.
Yes. Go ahead.
Hello, sir.
Yeah, go ahead. Go ahead. What is your question? What is your question?
I was just the last line. I was copying the last line.
Oh, this one is it? So have you done? You are copying this line, is it?
Yes, sir.
Okay. Now, basically, all these points are available in your tutorial handouts. You just need to fill in the blanks in the tutorial question handouts, right? Okay. We start deriving equation using the same diagram. So since we are relating the two body with a line, or in this case we call it chord, C-O-R-D, with the line, and the total length of the line, in this case, in all cases, we assume is not stretchable, means is always rigid. Means the length of the rod, the length of the rope here or the cord here doesn't change all the time. And we use L sub T to represent total chord. So you look at this diagram. This is the chord that you use, right? Are you able to derive the first equation for the total length of your rod? You take SA, or you take AC plus CD plus DB, or your SP, is the total length of the chord. So the first equation we derive is the length of the rope that you have in a system. If you have pulley system, okay, there will be something in the system that always fixed. In this case, the parameter that link body A, body B is the rope. Okay, and the rope always same, the length always same, it doesn't change. So you have total length equal to SA plus CD, length of CD plus SP. Okay. Next, in dynamic question, we are more interested in velocity and acceleration. Since you have the length and or that you have a displacement parameter here, we can use this equation to derive velocity for A and velocity for B. Before that, in this equation, there are a few things inside here that remain constant all the time. What is the you have 4 parameter, 1, 2, 3, 4. You have 4 parameter in this equation. There are some parameter inside here remain all the time is the same. For example, the total length of the rope or the cord always same. So if you divide over time, you get 0, right? And another one is the contact surface or the length of CD always same. No matter how you pull the A or you pull the B, the length of CD always same. The contact area on the pulley always same. So if you have the first derivative over time, you take LCD, the length of CD, divided over time, the rate of change of this length will be 0. It does not change, right? So 0. So inside this equation, you put this equation, divide by time. This whole equation is divided by time. SA divided by time, you get velocity for A. SB is the displacement done by the B. You divide it by time, you get the speed of P. Agree? You rearrange, you take this equation, divided by time, or you do first derivative over time, you arrive at this equation. dSA over dt plus dSB over dt equals 0. That's why LT and LCD was not inside this equation because it's already become 0. And you turn into something that related to this module, which is your V. I put as V sub A to represent object A velocity, V sub B to represent velocity of the object B. Before I move forward, any question from here to here? Anything that you're not sure? Why this one suddenly jump to this one? Okay. On.
No question, sir.
Our interest is to find the relationship between A and B. So you rearrange this equation. VB equal to negative VA or VA equal to negative VB. Correct? It is the same way. So either when you have positive VA, you get a negative VB. When you have and so on, right? You are using this equation. So you move either to the left-hand side, right-hand side, you still get the same equation. All right. So ask yourself, what do you understand from this equation? Why there's a negative sign there? Okay. It means your VB always have a negative velocity or negative direction of your VA. When you pull VA down, VB moving up. That's why this relationship tell you the relationship. If you pull B down, you get object A moving up. That's why you get negative here.
Hello, sir.
Yes.
So is all of this assuming that they have the same weight?
We're not talking about weight at this moment. We talk about what happened if you pull A and pull B. What happened to these two bodies? We more focus on the distance traveled by the rope, or the velocity of A, velocity of B, by assuming the length, the relationship, the thing that relate A and B do not change. It can be a chain, it can be even a more advanced technology, for example, wireless, that have a motor that rotate related to you program A move how much, B will move how much. Okay, so at this moment, the weight that is not a consideration. You focus more on the relationship between A and B. What happened if you pull A? What happened to B? In the velocity or acceleration context. And we still are focusing on the distance traveled by the object or by the rope. Okay, do you get it? Do I clear your question?
Yes, sir.
All right. The weight question will come into a few more chapters after this when we talk about rigid body. At this moment, we are at particles, where the gravity forces at this case we do not consider. Later we look at rigid body, then it become more complex. Still we use back the same concept, but we consider other motion criteria. Okay, so this is just an elaboration of what I say just now. When you pull A, what happened to B? When you pull B, what happened to A? You do the same thing. So velocity, you get this one. So it will happen the same thing for acceleration. So if B accelerate in this direction, you have A accelerate going up. You have a negative acceleration for A. In this case, the negative, it means direction of your acceleration. Direction of your acceleration. Negative in this case, again, is the direction of your acceleration. Same with velocity, is the direction of your velocity vector. It's not a deceleration, it's not slowing down, but it's a direction of your vector. Okay, if you understand this simple system, we move into more complex system in this diagram. So this one you can see in your handout, the version that I uploaded this morning. You can see the old version you don't have this one, but a new version that I just upload, you have this diagram. Okay, if you did look at this diagram, don't be scared by the diagram. Always refer to the three main keywords that we focused just now. Ask yourself, what is the coordinate system you have over here? Ask where is your origin. Ask where is your datum. Ask what is the positive direction for that particular object. Okay, now if you look at this diagram, you have two datum line there. One is for A, one is for B. and the rest is pulley and line. For object A, your datum is here. Datum A is to measure the displacement or the position of A, denoted by SA. And again, from this diagram, your positive direction of your SA is to the right-hand side. So we have a direction for SA, dot and arrowhead. So dot to arrowhead is this direction, positive. Label as SA. You label as the datum for object B. The datum for object B, it measures from this datum line to the center of this pulley. It labeled as SB. Again, look into the direction of your SB, dot and arrow, always dot to arrow. So going down is positive for B. Okay, then the rest is just some information for help you to relate the two body. For example, H. And yeah, in this case is the H. So again, when you look at relative motion between two body, ask yourself three questions. One, what is the coordinate system, or what is the origin of your object? What is the fixed point that you refer to? In this case, the fixed point here, it can be here, or it can be here. Okay, can be here or can be here, but in this case, the origin doesn't come into the issue. The second point is, what is the datum that you define for A and B? For example, A, you take datum on this here. So the positive direction for A is this way. Again, datum, the function of datum is to define where is the positive displacement, or what is the positive position for that object. Datum A, this datum give positive direction of A in this direction. This datum line give you the positive direction for B. Okay, as long as you're able to understand these three concepts, then you're able to answer all kind of questions that related to body. Okay, the next one, we still use back the concept that we derived for the diagram just now. So you look at the diagram, one thing linked to the pulley object is the chord line, right? It's the line that you use in the system. The line that you use in the system will not change. So are you able to find the total length of this object, of this diagram, by giving you the parameter SA, H, and SB? Are you able to relate the total length of the line in this system? Because it's the fixed thing that relate B and A, or A to B. Okay, look at the diagram. I give you 10 seconds to think about it. Are you able to write the equation for the total length of the chord line? LT or L equal to what? Okay, look at the diagram. Ask yourself, are you able to derive the equation for the length of the chord? Okay, all this already done just now. One is the length of the chord. The length of the chord give you by this length, SB plus SB plus H plus SA. Agree? The total length of your chord, plus this one, plus here, plus here, plus here. But however, this one was fixed. The red highlighted line here, basically they doesn't change all the time. So in your calculation, you can remove all the red color length. Okay, you can remove all this. Okay, that's why our total length in the system that will change, right? In the system that will change, we only focus on here, here, and here, and also here. So that's why the total length equation over here, you only have 5 parameters inside here, SB plus SB plus H plus SA equal to L. We take out the red color circumference of the pulley, red color circumference of pulley, and maybe quarter of the pulley over here. Because all this red zone doesn't change, and it doesn't help us to relate A and B. You know, they didn't change over time. So you rearrange this equation, you have 2SB there, rearrange, you get the equation for this system. 2SB equal to H plus SA equal to L. And again, this system is going to change all the time. Again, when you solve this kind of question, always orientate yourself to the 3 fundamental questions. Where is the origin? Where is the datum? Where is the positive direction? The next steps, you always derive the element that link A and B. In this case, is the chord line that always fixed all the time. In this case, we take the length of the changing parameter, in this case SB plus SB plus H plus SA. Of course, you can include the length of this one, the length of this one, the length of this one. Because later, when you change the length equation into velocity, you're going to remove all this segment into 0 because all this doesn't change. Okay. Next, we use this one to derive the velocity of A and B like what we did just now. Okay. You take this equation, divide over time, both sides. Length doesn't change. H is changing. All right. So, sorry, H. Yeah, the H is changing. So, sorry, H is constant because H is the, from this point to this point, they are fixed. Huh? They are fixed. They are fixed to the ground. So H is fixed. Huh? In this case, H is fixed because this pulley was fixed to the ground. So datum to this pulley to this pulley is fixed. So H is fixed. So in this equation, L 0. If you divide by time, this one 0. H also 0. So 2SB divided by time, you get 2VB. SA divided by time, you get VA. You move to the right hand side, you get negative. So for this kind of system, your relationship between A and B change to this equation. I hope you see the relationship between the first example and this example. Okay, there's no fixed equation for the relationship of AB, VA, and also acceleration. You need to look at the system, derive the relationship between A and B using something that relate to them. In this case, is the length of the chord. Okay, same, you change this equation to acceleration. So it means if you look at this equation, what does it tell you? If you move, okay, if you move B, A going to move in this direction 2 times of magnitude of B. If you move B 1 meter below, this one going to move 2 meter to the left, which get a negative sign. Agree? Okay, try to understand what is the equation that you get. Huh? In this case, if you move B going down with 1 unit, A is going to move 2 units to the left with negative sign. Okay, from here to here, also here. Okay, try to relate the first diagram and the second diagram. So you have a different system, a different equation. However, the approach still the same. Okay, you look at a coordinate system, you link something that always remain the same between A and B. In this case called length. And then you derive from position to velocity and acceleration. Let's look at another one, right? So this is just a illustration of what I mentioned just now. This is a diagram that I show you. This is another diagram, same system, same object, same position, but now I change my datum, not datum, but I change my datum reference system. You refer A and B. Datum for A remains same. Datum for A still same as A in this direction. H still same. However, my SB I change by referring a new datum over here. There are one more new datum over here where my SB now is measured from here to here. Where in this case, this new diagram, my SB position going up is positive. When the previous example I show you, your SB going down is positive. On the new diagram here, your SB direction is going up as positive. So when you derive equation also, it will give you a different set of equation because of the datum that you use. Because the movement is different already. Not movement, but the reference system different already. Because on the left-hand side A, your SB going down is positive. Second new datum here, your going up is positive. So your positive negative sign will be changing. You do the same derivation. Okay. You do the same derivation, you get the new equation. So when it comes to motion, relative motion in the question exam, we will always give you the datum. So you need to study carefully, right? So in this case, when we change our datum for B, your SA is positive. So the total length that you measure is a little bit different already. The same calculation, the same length, you take this one. The total length of the chord, that doesn't change. You take this one, plus this one, plus this one, plus this one, right? But because of the change of your datum, the calculation for this section is different already. Just now, this one to this one is SB. Just now, the diagram just now. Here to here is SB in the earlier example. Now your datum change already. What will happen? The same calculation, the same strategy, but to calculate the length of this one, you take H minus SB. Become this length plus this length. So you have 2 H minus SB plus H plus SA equals 0. You rearrange the equation. You get 2 positive value in this case. You get 2 VB equal to VA. What does it mean? If you pull VB down, VA going to move positive. Okay. In this case, right? If you pull A to the positive direction, your B going to move up, right? That's why your V is positive, because now your datum going up is positive. Okay? With BB, ask yourself, are you able to explain why in this scenario, once you change the datum, why over this side is positive, positive, and not negative? Okay. Previously, you have a negative sign there. Earlier datum, you have a negative sign here in this set A example. And set B, you get a positive sign for your between the motion of A and B because of the datum that you choose. Okay, so these slides just show you the importance of choosing datum and identify the direction of your SB and SA. Okay. Again, I label for you. Was it going up? Is it going right? Okay, let's look at one example and then we call it a day, right? You're giving one system like this. Determine the speed of block A if block B has an upward speed of 6 meters per second. Determine the velocity of A if this one moves up 6 meters per second. First, don't panic. Look at the diagram. Ask yourself, are you able to see the datum for the whole system? Datum line is this one. What is the positive direction from the datum for B? In this case, is give you here dot and arrowhead. Going down is positive for B. For A, C going down also positive, label as SA. And sorry, SB is from here to here. Okay, so going down positive. Okay, then all the red color you can ignore because they are always fixed. They're always fixed. So it doesn't help you when you calculate the velocity. Later on, it will still become 0. So ask yourself, after you identify the coordinate system, your datum, the direction of positive, next, try to identify what link A and B in this case. A and B was linked with this chord line. So derive the equation that link A and B with this chord length. So what is constant? Is the length of this line. Are you able to find the length of the chord that always change? Not always change, but the length of chord that help you to calculate the velocity? Are you able to find the total length of this chord line by looking at this diagram? You take here plus here plus here, which is equal to this one. So you have this one plus this one plus this one and plus this one. So the first equation is to calculate the item that link A and B at a constant parameter. In this case, it's the length of the chord. So the rest you can read from my slides. I already explained. So positive, negative. The next one will be the equation. Okay. So SA plus SB plus SB plus SB. The length equal to SA plus 3SP. Change this one into velocity. How do you change position into velocity? You take derivative over time or divide the whole equation divided by time. So on the left hand side, the total length doesn't change, right? The total length of the chord doesn't change. So on the left hand side equals 0. SA become VA, position become velocity, and SB become velocity V. Carry the constant 3 along. You get the first equation, not first equation, but velocity equation for velocity. Put the equation that related to A and B because this equation doesn't link. It's just a linear equation. So you put into V and A. Huh? So it already tell you that VB going up with 6 meter per second. Again, the direction compared to the positive one. When you want to calculate, always refer to the datum where is the positive. In this case, B move up. Move up means negative value of this one. This is magnitude only. Arrow represent positive or negative. So when you want to calculate VB equal negative 6 meter per second moving upward. There's a negative sign here because it's opposite from the datum direction. Put in there VA equal to negative 3 VB. Substitute minus 6, you get VA equal to 18 meter per second. In your calculation, you get a positive value of 18 meter per second. Refer back to your datum for A, where is the positive direction going down, positive. Because your answer is positive, your A moving down with 18 meter per second. Any question? Any question?
So that means to find the total length of the chord, we should neglect the velocity direction.
Again, your question?
To find the total length of the chord, we just ignore the velocity, the direction of the velocity.
No. Okay. You see the total length. Total length, how you find total length is from this point to this point to this point, right? You can continue to calculate this one. You can calculate. You can go and do some hard work here. You can calculate, give you the radius. You can calculate the circumference of this one, circumference of this one, circumference of this one. And I can even give you the length from here to here. You can include all this red color value inside this equation. However, when you change this equation into velocity, all this red color length doesn't change. It's always stay with this length. It's always stay with this length. Here to here also doesn't change. So you divide over time, this length divide over time in this equation. If you input all the red color in this equation, you still get 0. So that's why in this equation, I do not include here, 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 and here. Of course, if you're hardworking, you can input here, but it doesn't help your calculation for velocity. Do you see the reason why I do not put in the red color length inside here?
No, sir. My question is, the direction from the datum for SB is positive, and the direction of the velocity from B is going upward, so it's negative. So why the total length of the chord is L equals to SA plus 3SB?
Okay, I think you confused with the bottom one. Your question is you only consider that question when you seek for answer. I would like to correct your concept. Do you understand this equation?
Yes, sir.
Can you convert this equation into velocity? How do you convert this equation into velocity?
Differentiate.
Okay, so when you differentiate, the L become what?
0.
Okay, so SA become
VA.
VA. So the next one, 3SB become 3VB, right?
Yes, sir.
Become a new equation already. don't link this one to this one. This is for length, this is for velocity. You don't do the reverse one. This one is for the length. And just now your question is that why do we remove length? There's no length here. We already do the derivation here already, the differentiation here already. So those length that not relevant, okay, already become 0. So here to here you get velocity. So from here to here we only consider the velocity only, because why? Because when you move B or A, this is the relationship. Of course, you can use this one to calculate velocity. You still get the same answer because this one fixed already. This equation fixed. You can define A and B with the length equation, or you can define A and B with the velocity equation, or even you can relate A and B with the acceleration equation. So if you move 6 meters or go up, right? 6 meters go up, what will happen to A? You move up, A will go down. Move up, it will move move B up. Move B up, A go down, right? Correct? Move B up, A will go down, right?
Yes, sir.
So your question just now is ask me about datum, right?
Yes, sir.
So your reference datum is positive going down. All the direction you measure for your SB is positive going down. It means that all the velocity going down is positive. So in this case, your B is moving up, which is the negative direction of your datum. So in this case, you change the velocity become negative, which is going up. So you substitute into this equation, you will get VA become positive. So what I mean by positive? Mean object A will move down. You try to relate, maybe you are confused with the negative sign. Ask yourself why there is a negative sign for your VB. Huh?
I understand, sir.
Okay. All right. Any question? If no, I end the recording. You guys have other class, right?
Yes, sir.
Okay. I end the recording. If you have a question,